solving a system. What's the question? It says inequalities quest. Okay? Inequalities. Linear quadratic equations. Okay, you remember what a system was from grade 10? You remember that was the last stuff we did? Two lines. By the way, some of you seem to have forgotten the equation of a line. If they cross, that's what we call the solution. That's when the coordinates of this line are the same as the coordinates of this line. There's only one possible point for two lines where they're going to cross. Okay? But you could have two lines not cross. They could be parallel and have different y-intercepts. Those will never cross. Okay, now, you know they'll never cross. That's my sign for parallel. Okay? Or I could have one line right on top of another line, and you have infinitely many solutions. Like there's a point that's the same on both lines. Here's another one, here's another one, here's another one. It's infinite. Okay? This is the same thing, only you don't have two lines. You got one line and one parabola. Okay? Linear quadratic system. Oh, look. A line and a parabola. Let's read this. In calculus class, which you all will do if you're taking science at secondary education, in order to determine the shaded area in the diagram between the parabola, the most basic one we could have, y equals x squared, and the line, y equals x plus 6. Let's go over this again. What does the 6 mean? Y is mx plus b. That's b. What's b? That's the y-intercept, right? X. What's the m before the x? That's the slope. Here there's no number, so that means it's a 1. The slope is 1, right? 1 unit of rise, 1 unit of run, that's a 45-degree angle, okay? If the rise is the same as the run, that's an isosceles triangle. If you remember trig, that would be 45 degrees. Okay, it's necessary to determine the points of intersection of the parabola and the line. Okay, that's why we call this pre-calculus. We're not doing calculus. It's the stuff you hopefully know before you do the calculus. Okay? All right, so use the intersect feature of a graphing calculator. Do you think we would do that? Okay, I'm not going to focus on that. If you can do that, great. If you want to ask me later, great. But I want to do this. Use the method of substitution or elimination to algebraically determine the coordinates of the points of intersection. So, two lines. We want to know the solution. When does this line equal that line? When are they the same? Well, same thing. I want to know when this line equals this parabola. Okay? Here's the equation for the line. Here's the equation for the parabola. When are they the same? Do you remember substitution? Do you remember elimination? Which method would you like to use here? If you know one thing, like y, you substitute it in the other equation, okay? And you have one equation with one variable, and hopefully you know how to solve that, okay? I know what y is, it's x squared. I also know y is x plus 6. So take this y and substitute it right there. X plus 6 is x squared, right? Y equals y. That's all it says. When does this line equal the parabola? Graphically, right there and there. Okay, I substituted. Right? Okay, there's lots of ways to think about it. So, solve it. And again, do I want to bring this over here and make it minus, or do I want to keep it there and make it plus? One way I get a parabola upside down, the other way I got a parabola right side up. These points are going to be the same, but you see my picture? Is that positive x squared? So you try to be consistent. Let's keep this positive. Okay, let's get minus x over to that side, like minus x to both sides. Okay, let's get 6 over there, minus 6 to both sides. Okay, so I got x squared minus x minus 6. There's nothing left on the left side. Okay, or x squared minus x minus 6 is 0. Okay, are you okay with that? Where's x 0? Do you see, Brenna, what x has to be for this to be 0? Or do we want to do something else? Let's solve it. Can I factor that? Life would be nice if I could. What multiplies to negative 6 and adds to negative 1? What two numbers? 6 and 1. Oop. Yeah, I don't know if I can't really add those. I can add those to 7, or I can add them to 5. Okay, that's fine. It's okay to think out loud. Okay, that doesn't add to negative 1. That's got to be a negative, so I want the minus there. Okay, double check it. Do those two things multiply to negative 6? Yes. Do they add to negative 1? Yes. Throw down 2 sets of brackets. Those are your two numbers. Now do you see where this thing could be 0? What values of x? 3 and negative 2. Okay? Does that kind of look like negative 2? Kind of does to me. Does that kind of look like 3? Sure. Okay? So again, if you got a graphing calculator, hey, feel free to check. Okay? That's when that thing works. When x is this, or x equals that. Okay? That's what x is. But what are these actual coordinate points? Do I know what y is? I don't want to guess. How can I find out? If x is 3, and I plug it back in here, okay, it says the coordinates of the points. It doesn't just say x, right? So x, if that's x, what's y? Well, y is x plus 6. 3 plus 6. Y is equal to 9. Okay, if x is 3. Or y is, if x is negative 2, y is equal to 4. Okay, so go back and check. Does that kind of look like 4? 1, 2, 3, 4. Yeah, sure does. Does that kind of look like 9? 1, 2, 3, 4, 5, 6, 7. Yep. Okay. There's the two solutions. Think I could have any more? Or is 2 the most I could get when crossing a line and a parabola? Could I have any less than 2? Okay, so that's substitution. What does elimination look like? I want to subtract the lines, or add the lines, or multiply both lines by some number like 2, 3, 4, or 67, whatever is going to help you. Quickly, let's just subtract these. If I subtract that from that, what happens to my y's? They're gone. X minus x squared. 6 minus nothing is 6. Do I get the same thing? Sure do. Oh. On the other side. 6 minus 0. Oh, they should be the same.
It's the same thing. It's just
Okay. All right. Well, I don't think you'd want to do elimination here anyway. I think substitution's the better way. I'm making a mistake. All right. Verify. How do you know if that works? If you plug them both back in the equation, it'll work. Okay? Is 9 equal to 3 plus 6? Yep, sure is. Is negative 2, no, sorry, is 4, is y equal to x plus 6? Is 4 equal to 4? Yes, it is. Okay? I verified them both in the line. Now let's verify them both in the quadratic. Okay? Is 9 equal to 3 squared? Yep. Is 4 equal to minus 2 squared? Yep. Okay? Verify. You had to do it 4 times just to double check. Okay? So those are your 2 solutions. The solution, well, as coordinate points, 3, 9, minus 2, 4. Okay, investigate. Let's do this pretty quick. Of course, this thing's honking big. There is the graph of that. Now this one's a little trickier, right? How do you know that's the graph of that? Any way of telling what the vertex is here? Do you remember how we can get the vertex out of that? Yeah, what is that called again? Completing the square. Are we all going to know that in a week and a half? Hope so. Okay, so that's the graph of this parabola. Let's see what happens if we take this line, 3x, and stick that on the graph. Okay? What's the points of intersection? All right, well, where is this equal to that? Where is 3x equal to x squared minus x minus 12? Excuse me. Okay, let's solve that thing. Make a trinomial. With any luck, it'll factor, and life will be grand. Okay, take 3x over to that side. So I have x squared minus 4x minus 12 is 0. Okay, if you like to do that a different way, feel free. What multiplies to negative 12 and adds to negative 4? Nice. 6 times 2 is 12. One of these has got to be negative, and I need a negative 4x, so put it on the bigger one. But double check it, right? Don't just go on. Double check. Does that work, Jake? X squared minus 6x plus 2x is minus 4x minus 12. Yes, it does. Okay. When's this thing equal to 0? When x is minus 2 or 6. Okay. That's just the x coordinates of my point of intersection. What's y? Okay, well, let's use the easy one. Y is 3 times x. Okay, so I have minus 2, minus 6, and also y is 3 times 6, which is 18. I have 6 and 18. How can I check that? Graphing calculator, or, hey, do I got a graph here? What does this look like again? Y is 3x. That's 3x plus 0. It goes through here, doesn't it? I have a slope of 3. 1, 2, 3. 1 unit there. 1, 2, 3 there. 1, 2, 3 there. 1, 2, 3 there. Let's keep going. 1, 2, 3 there, 1, 2, 3 there. Oh, look at that. Is that point right on the curve? What's the coordinates of that point, do you think? Is it like 6 and 18? No, it couldn't be. Could it? There it is. Okay. That's what your line looks like. Guess where the other point is? Let's have a look. 1, 2, 3 units of rise, 1 unit of run. 1, 2, 3. Hey, look. -2, -6. Okay? So that's kind of like the example we first looked at. There's a line. There's a parabola. Okay, where do they intersect? Make one thing equal to the other thing, called substitution. Okay, find the 2 points. Repeat. Now we got this line and that parabola. Okay, so where is this thing, y, equal to this thing, y? Right? Where's y equal to y? So solve that guy. Again, let's try to make x squared positive. Okay, it's not totally wrong if you make it negative, but this is a positive parabola, so let's be consistent. So minus 3x to both sides, add 16 to both sides. Okay, gone, gone. 0 is x squared minus 4x plus 4. Got it, Tobias? Can I factor this? Is there something that multiplies to 4 and adds to -4? Two times 2 multiplies to 4. Okay, and 2, -2 and -2 add to -4. Does it work? Sure. What's my solutions? Tanner? 2 and? 2 and 2.
Wouldn't that just be 2 then?
Aha, you remember we kind of talked about this. That's called a double root, right? Look at the most basic parabola. What's my zeros here? Zero and 0. It's a double root. Okay? Yeah, there's only one answer. 2 is 2. If I graph this thing, 3x minus 16, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, whoop, 1. That's what my line looks like. It doesn't cross it. It just touches it in one spot. This says that's right here. That's called a point of tangency. Okay? It's still a root. Technically, it's called a double root. Okay? It's only one point. Okay? It just touches it. It doesn't cross it. So you can have one point. What's the other situation? I'm not even going to worry about getting the y-coordinate there. Looks like minus 10. Could I possibly draw a line that doesn't cross this graph? Reese, what do you think? Could I draw a line somewhere that doesn't cross this parabola? Why the heck not? How about right there? Right? Let's see. Repeat. For this line, when is this equal to, what's the parabola? X squared minus x minus 12. So let's think, I already told you kind of what we're doing. Are these things going to cross? Should I get a solution? Try to keep that in mind. Let's minus 3x to both sides. Let's add 24 to both sides. Gone, gone. X squared minus 4x plus 12 equals 0. What multiplies to 12 and adds to negative 4? 6 and 2. Come on. Like, you can get negative 4 to that. Come on, right? There. Those add to minus 4. What does it multiply to? Yeah, okay, you got me. It doesn't work. Can't do it. How can you solve a trinomial if you can't factor it? All right. Stupid quadratic. When are we ever going to use this in the real world? It just sucks. Okay. A is 1. B is negative 4. C is 12. Plug them in. Minus 4 is plus 4, plus or minus the square root of negative 4 squared. That's just same as 4 squared. 16 minus 4 times A is 1, C is 12, all over 2 times 1. Okay? 4 plus or minus the square root of 16 minus, what's 4 times 1, Dannon? 4 groups of 1. How do you even do that? Can I remember? What's 4 groups of 1? I think it's 4.
Sure.
What's 4 times 12? I got 16 minus 48. What's that? Is that minus 32? Shoni, what do you want to do at this point? So what would you like to do at this point? You would come to the conclusion, you can't do that. No solutions, and we already knew that. We kind of cheated, right? I knew where that line goes. 3x minus 24, where is that? 1, 2, 3, 4. There it is. No, it's parallel to those ones. There it is. Doesn't cross it, no solutions. You could have that happen, okay? Okay? If we have 2 points where it crosses, we have 2 solutions. If it touches it at one point, we call that a point of tangency. Okay? Or it doesn't cross. They do not intersect. No solutions. That's your 3 choices. Could anyone come up with a different one? I don't think so. All right. Is there a way to find out if some trinomial is going to have a solution or not? You remember the discriminant? Okay, just as a friendly little reminder, you'll get a discriminant question on your final. If this thing is positive, then we have 2 solutions. If this thing is 0, then we have 1 solution, i.e. a double root. If this thing's less than 0, if it's negative, then we have no solutions, because you can't take the square root of a negative, at least not yet. You guys will learn how to do that later. When you're big kids. Okay? 1 to 3.